In this video, we'll be learning to solve systems of two linear equations by the addition method, sometimes called the elimination method. I actually like both names because we're going to add, and during that addition, we're going to eliminate a variable. Our steps to solving systems of two equations by this method is first, you want to arrange each equation in the form ax plus by equals c. See, we want everything like terms to line up vertically. You're going to multiply one or both equations by the appropriate numbers so that the coefficients of one of the variables are opposites. We want this because when we add down, the variable should drop out. Then solve for the remaining variable. You want to then substitute this value into one of the original equations and solve for the other variable. Write your solution as an ordered pair x, y, and you can always check your solution by plugging it into both original equations and make sure you get two true statements. So let's solve by elimination. We start by making sure that all of our terms line up vertically. We want x's, y's equals constants. They do. Now you want to check to see if you add down right now, would one of the variables fall out? Notice that the coefficients on the y's are opposites. If we add negative y with positive y, they're going to fall out. This is perfect. This is what we want. So I'm going to add down. X plus 3x gives me 4x. Negative y plus y, those fall out. And 6 plus 10 is 16. We now have the equation 4x equals 16 that we can solve. Dividing by 4, we get x to be equal to 4. Now we need to find the y value. We can do that by plugging 4 into either of the two original equations and solve for y. I'm going to choose the top one. Doesn't matter, you'll get the same answer either way. So 4 minus y is equal to 6. Let's subtract 4 from both sides. Negative y is equal to 2. And then dividing both sides by negative 1, we get y to be equal to negative 2. We want to write our solution as an ordered pair. The solution of the system is the ordered pair, 4, negative 2. In our next example, we want to start the same way. We want to make sure that things line up vertically. We have our x's, our y's, our equal sign, and then our constant. Then we check to see if we add down right now, would one of our variables fall out? Do one of our sets of variables have opposite coefficients? They don't. What we need to do is multiply one or possibly both equations by a constant that would cause the coefficients to be opposite of each other. Say I want to knock out the x's. I need those numbers to be opposites of each other. Notice if I multiply 2 by negative 2, I would get negative 4. Negative 4 is opposite to positive 4. So that's the move we want to make. We want to multiply each term in that first equation by negative 2. That's going to give us the equation negative 4x plus 6y equals negative 18. Our second equation stays the same. Next, we want to add down, and those x's should fall out. Our x's do fall out, negative 4x plus 4x, those fall out, but notice our y's do as well. A positive 6y minus 6y, Those cancel out, and we're left with just 0 on the left-hand side and negative 14 on the right. This is a false statement. Anytime you're solving a linear equation in one variable and you get a false statement, that means that there is no solution. This system has no solution. If we were to graph these, the lines would be parallel and never intersect.